Hi everyone, today we're going to be doing linear modeling, where we write equations of linear functions using points and slope. So just to get our brains warmed up, let's go ahead and determine a reasonable domain and range for each situation. Okay, the first one says a professional basketball player earns $150,000 for each game played, and there are 82 games in a season. So we really have to think about cause and effect here. Does the players earning $150,000 determine the number of games, or does the number of games they play determine how much money they earn for the season? Well, the number of games is going to determine the amount of money that the players make. So domain, remember domain is going to be your input values, which are normally your x values. And range is going to be your output values or your y values. Okay, domain, those are your x values or your input values. Range, that's going to be your y values or your output values. So let's talk about the number of games possible. What is the lowest amount of games that you can play? That would be 0. So the number of games you play is going to be sandwiched somewhere in between 0 and 82 games. What about the range? How much money you make? Or can you make? If you play no games, how much money are you going to make? You're going to make absolutely no money at all. What's the most amount of money you can make? Like if you play all 82 games, how much money are you going to make? Well, if you play 82 games, and each game you make $150,000, I would multiply 82 by 150,000 in order to determine how much money I'm going to make. That's going to end up being $12,300,000. Wouldn't that be nice to make that much money? Okay, let's look at number 2. You eat up to 5 meals a day with an average of 844 milligrams of potassium at each meal. Okay, so is the number of meals going to determine the potassium, or is the potassium going to determine how many meals you eat? The number of meals is going to determine how much potassium you're eating. So we're going to say that our input is number of meals, and our output, or the range, is going to be the potassium. Okay, so what's the lowest amount of meals you can eat in a day? You could technically eat no meals. And what's the most we're going to see? It says we're going to eat up to 5 meals. Okay, what about the range? It says that you have an average of 844 milligrams of potassium at each meal. So if you eat no meals, how much potassium are you intaking? How much potassium are you taking in? 0. What's the most amount of potassium we could eat per day? If we have 5 meals, and at each meal you eat 844 milligrams of potassium, what is the total amount? Well, if I multiply those together, we get 4,220. Okay. The average amount of money spent on food per person at the amusement park that can accommodate 2,500 people is $5.25. So is the amount of money spent on food going to determine the number of people in the park? Or is the number of people in the park going to determine how much money you're spending on food? Well, the number of people that are coming to the park is going to determine how much money is spent on food. So we're going to say that the input or the domain is number of people. So what's the lowest number of people that can come to the park? Well, no one could come to the park. That's possible. What's the most people that can be in the park at one time? Well, it says the park can only accommodate 2,500 people. So I'm going to say that the max would be 2,500. So how much is spent on food? Well, if no one's in the park, there's no money spent on food. What's the most amount of money? Well, if all 2,500 people are in the park and a meal is $5.25, how much money would be spent on food ultimately? We would get $13,125. And there we go. Okay, today we're going to do more writing equations of lines. We've already reviewed this. If you have the slope and y-intercept, you're going to use slope-intercept form. If you're given the slope and a point, you're going to use point-slope formula. And if you're given 2 points, remember that's 2-part process where first you have to find the slope and then you're going to use the point slope form. Okay. So in example 1, it says writing a linear equation from a graph. The graph shows the distance the asteroid travels in x seconds. Write an equation of the line and interpret the slope. Okay, so let's first identify the y-intercept. The y-intercept is where the graph crosses the y-axis. So here's the y-axis. Okay, if you think about extending this, you could get all 4 quadrants. It's really just showing us one of the 4 quadrants, right? So the red is the y-axis. Where does it cross the y-axis? Right here. So I'm going to say that my y-intercept is 0, 0. And what is the slope of that line? Well, there's 2 different ways you can do slope. You can either use that formula, y2 minus y1 over x2 minus x1 to get the slope, or you can just count boxes. Okay, remember slope is also rise over run, so you can count how much you're going up or down and how much you're going left or right. So I'm just going to go ahead and use rise over run here. It looks like I'm rising 24, and then I'm running 5 in order to get to that next point. Okay, so for slope, I'm going to say that we rose 24 and we went right 5, and then I'm going to simplify that. Which 24 over 5 doesn't simplify. You could write it as a decimal. This would be equivalent to 4.8 as well. Okay, we really don't want to round. 4.8 is not rounded at all. That is an exact value. We call that a terminal decimal. Okay, if you wanted to use the 2 points, you could use 0, 0 and the 0.524 to calculate slope. You would just do your y2 minus y1 over x2 minus x1, and we still get 24 fifths. Okay, so you have some flexibility there. Okay, now that we have the slope and the y-intercept, we can write our equation using slope-intercept form. The slope was 24 fifths, or you can put 4.8. I like decimals for real world contextual situations, as long as, like I said, it's a terminal decimal that stops, it's exact. Plus b, well my b value is 0, so really I don't have to put the plus 0 on there. 4.8x is fine. Okay, let's go ahead and interpret the slope. That's the next part, is to interpret the slope. What does the slope mean? Like if I'm thinking about slope being rise over run, what is my vertical axis, or what is my rise axis telling us? That's miles. Oops. What is my vertical axis telling us? That's miles. And what is my horizontal or my run axis telling us? The seconds, right? Time. So really what this means is miles per second. Okay, so that would say that the asteroid travels 4.8 miles per second. Okay. It says the asteroid came within 17,200 miles of Earth in February. About how long does it take the asteroid to travel that distance? So what we're given is the distance, right? The distance is 17,200. Okay, so what is distance? Is that x or is that y on our graph? Let's look at the axis. The axis, we see that distance is actually going to be our y values. See how that's the y-axis? So we know that y is equal to 17,200. So in our equation, y equals 4.8x, all I have to do is plug in the 17,200 for y to solve for x. Okay. what would I do to get x by itself? I'm going to divide both sides by 4.8. Okay, and x would be approximately what? Go ahead and just give me a rounded answer to the nearest second. 17,200 divided by 4.8. We get 3,583.3 repeating. So I'm just going to round down to 3,583. Remember, that's seconds. So we have about 3,600 seconds, which if we divide that okay, so we'll say about 3,600 seconds. And really there's about 3,600 seconds in an hour, so we could say that it takes about 1 hour for the asteroid to travel those 17,200 miles. It's moving pretty fast. Okay. The graph here shows the remaining balance, Y, on a car loan after making X monthly payments. Write an equation of the line and interpret the slope and Y-intercept. What is the remaining balance after 36 payments? Okay, so let's go ahead and start with writing an equation of a line. We know the y-intercept. Do you see how it crosses the y-axis at 0, 18? And I just need to know the slope. So you can, again, count boxes to know the slope. You just have to be really careful. If you're counting boxes, like looking over here at this picture, let me zoom in on it a little bit. Notice the intervals that we're using. This isn't going up by ones. We go up by what each time? This would end up being 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So see how we're going up by units of 3 each time? And what about on the x-axis? 0, blank, 10. That would be 0, 5, 10, 15, 20, 25, 30, etc. So it's going up by 5s each time. So if you're going to count boxes, be careful. Like I've had people in the past tell me that the rise was -1 and then the run was 2. That's actually not correct here. Like really, what's my rise? I'm going from 18 to 15, that would be down 3. And then I'm running, instead of just 2, we'd be running 10. So I really get -3/10 there. So just be careful if you're counting using the picture. Sometimes it's a safer bet just to use your slope formula. Okay, so what I mean by slope formula is the y2 minus y1 over x2 minus x1. And in this case, I'm going to use 2 points on the line. I'm going to use 0, 18, and I'm going to use the point 10, 15. Okay, so my slope is going to be 15 minus 18 over 10 minus 0. So I get -3 over 10. There you go. If you want to write this in decimal form, that is equivalent to -0.3. So either one would work there. Okay, so in part A, we wanted to write the equation just using y equals mx plus b. I'm going to plug in -0.3 for m, and I'm going to plug in the 18 for the y-intercept. That part's done. Okay, now we want to interpret the slope and the y-intercept. Okay, so we're going to do, for the second part, we're going to do an interpretation for the slope. And the y-intercept. Okay, so what does the slope mean? Remember, slope is rise over run. So let's look at our axes here. What is the rise? That's the balance in thousands of dollars. Okay, so we're going to say that it's money, right? the balance. And what's the run? The run is number of payments. So really this is the money per payment, okay? We could say that -3/10 means that we're going down a certain dollar amount per every 10 payments. And the reason why this is so tricky is because notice that my y-axis here is written in thousands of dollars. So rather than just saying we're going down $3 per 10 payments, it's not just down $3. We actually have to move this decimal place over 3 times in order to get the amount of money we're going down each time. So again, the reason why I'm moving the decimal over is because the first time is 10th, then 100, and then 1,000. Okay, you could also multiply 3 by 1,000 in order to get how much money you're going down every 10 payments. So I'm saying we're going down $3,000 per every 10 payments. Okay, let's go ahead and do the y-intercept interpretation. The y-intercept is 0, 18. Remember, 0 is your x value, which represents number of payments. So when you've made no payments, and what's y represent? That's balance in thousands of dollars. When you've made no payments, you have 18 what? Well, I have to multiply that by 1,000, remember? I have $18,000 left. I mean, let's just think about this. Okay, we're dealing with a car loan. When you buy a car, you're going to owe a lot of money on it, right? And then as you start making more and more payments, then the balance that you have remaining goes down. So when you start off, when you haven't made any payments yet, the car was $18,000. And that's why with the slope, it's so important to know that every time you're making 10 payments on it, the amount that you have left to owe is going down by $3,000. Okay. You could even write this slope interpretation as going down $300 per one payment if you wanted to divide by 10, so you could figure out how much it's going down each time you make a payment. Okay, but with the y-intercept interpretation, I'm just going to say that the starting loan balance is $18,000 before any payments are made. Okay. The last part says, what is the remaining balance after 36 payments? So remember, x is number of payments. So after 36 payments are made, what's the remaining balance? Well, I'm going to use this formula that we came up with in part A. So we'll have y equals -0.3. I'm going to plug in 36 for x and simplify to figure out what my balance is. Okay, so we have -0.3 times 36 plus 18. I'm just popping this in my calculator, and we have 7.2. Which, remember, 7.2, y is written in thousands of dollars, so if I multiply this by 1,000, or if I move the decimal over 3 times, I would really get that a balance of $7,200 remains. That's a lot of payments, and you still owe over $7,000. Okay. Let's go ahead and take a look at this problem. We've got 2 prom venues that are charging a rental fee plus a fee per student. The table shows the total cost for different numbers of students from Lakeside Inn and the total cost Y in dollars for X students at a Sunview resort. That's represented by the equation 10x plus 600. Okay, in example 2, we have 2 prom venues that charge a rental fee plus a fee per student. The table shows the cost for different numbers of students at Lakeside Inn. The total cost for X students at Sunview is represented by this equation, 10x plus 600. Which venue charges less per student? When you see that word per, I'm instantly thinking slope. How many students must attend for the total cost to be the same? Okay. So let's go ahead and start out just by taking a look at this chart for Lakeside Inn. Okay, it says, how do we know that the table above shows an exact linear relationship? Okay. Well, if you want to know that there's definitely a linear relationship, you're going to look at the first differences for y's and the first differences for x and make sure that it's it's consistent. So we want to have the same first differences for y given that there are consistent first differences for the x values. Okay, so let's check x values first just to make sure there's consistent first differences. How do I get from 100 to 125? What is 125 minus 100? That'd be 25. To go from 125 to 150 is 25. To go from 150 to 75 is 25. And then finally, 200 minus 175 is still 25. So that checks off. There are consistent first differences for the x values. So now that I know that we have consistent differences for x, we've got to make sure that the y values are also consistent. So what's 1800 minus 1500? That's going to be 300. If I add on another 300, I get to 2100. Add on another 300, I get to 2400, etc. So all the y values also have consistent first differences. Okay, so we're going to use this information to find the equation for Lakeside Inn. I'll just label this Lakeside. Do I know the Y-intercept? No, I don't right now. I could work my way backwards if I wanted in order to get 0, something. Or I think it might just be easier to use point slope formula. Okay, so I'm going to just pick 2 points on the line. So I'll pick, let's just pick the ones with the lowest values. I'm going to pick the 100, 1500, and the 125, 1800. And I'm going to use that to calculate the equation for Lakeside. All right, let's first find the slope. The slope, we'd have y2 minus y1, so I'll have 1800 minus 1500 over x2 minus x1. We get 125 minus 100. Okay, the difference in the numerator is going to be 300, and the difference in the denominator is going to be 25. And if we reduce that, that reduces to 12. Okay, so my slope is 12. I'm going to use a slope of 12, and I can just pick one of the points to use. So I'm going to use the point 100, 1500. Okay, so now I'm using this point slope form, y minus y1 equals m x minus x1 to get my equation. I'm going to label this point x1, y1 so I can easily plug it in. We get y minus 1500 equals 12. X minus 100 is x1. Okay, let's just simplify it to get it in y equals form. So we have y minus 1500 equals 12x minus, multiplying by 100, we just move the decimal over twice, so that would be 1200. Okay. Then we'll add the 1500 on both sides, and we get y equals 12x plus 300 for Lakeside. Okay, and I already have the equation for Sunview, right? For Sunview, it gave us the equation y equals 10x plus 600. Okay, now the question is, which venue charges less per student? Let's think about the slope interpretation here. We have rise over run, so that would be cost over student, or price per student. So really the slope means price per student. So where Sunview charges $10 per student, Lakeside charges $12 per student. Okay, so which venue charges less? For part A, I would say that Sunview charges less per student. Okay, the next part says how many students must attend for the total cost to be the same. I'm not going to spend a lot of time on that just because I want to get to the last example. Okay, so I'm not really going to worry about that. But if you wanted to solve it, because your equations represent cost functions, all you have to do to figure this out is set the equation of Sunview equal to the equation of Lakeside, and you solve for x. I believe that you get that x is 150. The total cost is the same when 150 students attend. Okay, I want to make sure I get to this one. There's a similar question in your homework, so I want to make sure we get to it. It says you want to make a recipe that calls for 1 3/4 cup of flour, but some of the markings on your measuring cup have been worn away over the years. Oh no. You can still see the half cup and 1 cup lines on your measuring cup, and you can still see all of the ounce markings. It is visible that half a cup is 4 ounces and 1 cup is 8 ounces. So they give us a relationship, right? Half a cup's 4 ounces and 1 cup is 8 ounces. Write an equation that represents ounces in terms of cups. So this wording is weird, which is why I want to go over this. Ounces in terms of cups. That wording is just so strange. When you see that, what that means is that my input, or my x value, is going to be cups, and they want that to determine the number of ounces for your output. Okay, so let's just think about how we would write that relationship as an ordered pair. It tells us that half a cup is 4 ounces, so I'm going to write a point at 0.5, 4. Right? My input is cups, my output is ounce, and then it also gives us that 1 cup is 8 ounces. So again, my input is my cup, and 8 ounces would be the output there. Okay, so write an equation that represents ounces in terms of cups. What we have to do is find the slope. Let's do that first. 8 minus 4 over 1 minus half. We end up with 4 over half. Right? Rather than dividing by half, we can multiply by the reciprocal. Right? If I flip 1 over 2, I get 2 over 1. So I get that my slope is 8. Okay, slope is 8, and we just pick one of those 2 points to use in our point slope form. Okay, so I'm going to use 1, 8. So now I'm plugging that information into my point slope form. We'll call this my x1, y1, and I already know my slope. My y1 is 8, m is 8, and x1 is 1. Okay, just distribute that 8 through so we can try to simplify this. We get 8x minus 8 when we distribute. And if I add 8 on both sides, oh, look at what happens if I add 8 on both sides. Really, that just goes away. So I get y equals 8x for part A. Okay, so I did part A. Write an equation that represents ounces in terms of cups. Check. Okay, so now I'm going to do part B. Part B says use your equation to estimate how many ounces are in 1 3/4 cups. Okay, use your equation to estimate how many ounces are in 1 3/4 cups. So X is your input. We're inputting 1 3/4. I think it would be easier to write this as an improper fraction. So what's 1 times 4? That's 4 plus 3. That'd be 7/4. Right? Another way you can think about it is if you have 1, that's 4/4. And then I still have to add on the 3/4, which gives us 7/4 for x. Okay, so I'm going to plug that in for part B. So for part B, we're using our equation from part A, and I'm plugging in 7/4 for x. Okay, so I would end up getting what? That would end up being 14. So I get 14 ounces. Okay, there are 14 ounces in 7/4 cups. Part C is quite tricky. I'm going to do part C just in black. It says rewrite your equation in part A to represent cups in terms of ounces. Okay, this is weird. So now for part C, we're writing cups in terms of ounces. So my input and output values are changing. The easiest way I can think to do this is just to solve for the opposite variable. So instead of having y by itself, let's get x by itself. So I'd get 1/8 y equals x as well. Okay, we just want to get the other variable x by itself in order to write an equation of cups in terms of ounces. Now if I plug in the ounces, I can quickly simplify to get how many cups.